Good day and welcome. I'm Mr. Simons. Now here we'll be looking at some Theorem 1 to Theorem 4 problems. Chosen them all from past exam papers. Just to practice your theorem so that you know how to solve. Now if you look at the first problem, this one comes from November 2014, paper 2, grade 11, and question 8. Now this is grade 11 and grade 12. You need to know it for both grades. Right, in the diagram they say O is the center. So O is the center of the circle passing through A, B and C, CAB. So CAB is 48 degrees, COB equal X, and C2 here equal Y. Right, and they want us to calculate with reasons the size of angle X, the size of angle Y. And the drawings I've brought in some color because in theory geometry is just testing your observation skills and do you understand how each theorem is. So I've tried to point out each theorem using different colors. So let's look at the solution. So right, to get X, see the X has two pink lines to form vertex O. And it's resting on this line CB. So X is subtended by the chord CB. Right? If you look at the angle here by the circumference 48, that there, if I go back with the two purple lines, is also subtended by CB. So therefore, angle at center equal 2 times angle at circumference. I hope you see there, they both are subtended by the same chord. So therefore for X, this would be 2 times 48. My reason angle at center equal 2 times angle at circumference. And that would give me 96 degrees. Right? Then they want the size of Y. Given that C2 is Y. So we assume, you know, that OC, any line from the center to the circumference, and OB there, both are radii. So we always put in the secret isosceles triangle, and if you don't get used to it, you will be caught out. So to get the size of Y, I need to understand that C2 and P2 has to be the same size. Equal sides, there OC and OB are equal sides, will form equal angles. Right, so therefore 180 minus the 96 there, divided by 2, because I have two angles at the same size, gives me 42 degrees. Right, so equal sides, equal angles, and at the same time, angles in a triangle equal 180 degrees. Right, so 2 marks each, 4. Let's look at the next problem. Right, now the second problem, this one is from November 2014, paper 2, question 8. They say in the diagram below, PT is the diameter with center O. So from P to T is the diameter. M and S are points on the circle on either side of PT. And then they say that angle M2 equal 37 degrees. Calculate with reasons the size of angle M1, size of angle O1. Right? So if you look at the solution, right, they want size of M1. Right? If PT is a diameter, according to Theorem 3, any angle formed off a diameter, you see there where the two where the two blue lines meet, right, it will always form a 90-degree angle. No? My reason is angle in a semicircle. So to get M1, I need to understand that M1 plus M2 equal 90, because it's an angle subtended of a diameter. So M1, 90 minus 37, gives me 53 degrees, and my reason, angle in semicircle. Right, so I hope you can see them. Right, if we go to the second problem, so you calculate the size of O1. So they want the size of O1 there. Take note, I just solved M1. M1 is 53. Right, and you see they have colored it in to show you what you're looking for. So when I look at O1 here, I go back with a line OS, and I go back with a line OP. See that's resting on that arc PS. Ne? But if I also go back with angle M1, That stops by P, MP and MS. Those two blue lines also stop on the arc PS. Therefore now I can say angle at center, there in the middle, equal 2 times angle at circumference. So 01 here then technically equal 53 times 2 degrees, which gives me 106 degrees, and my reason, angle at center equal 2 times angle at circumference. So I hope you understand. I'm going to do a second set. Drawing wise take time. I will also do third and fourth and so on as the year goes on, all hoping to improve you. If you're enjoying the lesson, please like, share and subscribe.